So hello everyone, my name is Susan Seth and now I will start the topic gravitation. So gravitation means gravity or the gravitational force. So it is derived from the Latin word gravitas, okay, which means weight. So if you tell anybody that the weight of an object is this, means you are saying that the gravitational force experienced by this body is this. The force is experienced in, means the unit of force is Newton. The unit of weight is also Newton. So gravitational force is measured in Newton. Now it is a fundamental force. It is one of the four fundamental forces in nature and it is the weakest among them. Okay. Now it acts on anybody. Anything that has mass will face the gravitational force. Okay. So whether it's the inhabitants of the earth itself, the satellite of the earth which is moon, or planets, sun, stars, anything that exists in the universe experience this force. Means anything that has mass will feel the gravitational force and also will impart the gravitational force on another body. Okay, so it is acting everywhere between us and the earth and the moon, between us and the moon, between the planets and the sun, and between any two bodies in the universe that has mass. Okay. Now this gravitational force obeys the third law of motion, okay, which is Newton's third law of motion. Means every action has an equal and opposite reaction. It means the gravitational force of body 1 on body 2 is equal and opposite of the gravitational force of body 2 on body 1. This will be seen in the next slide. Okay, it will be easily understand using that slide. Now as I have said, this is the smallest among the four fundamental forces of nature, which are gravitational force, electromagnetic force, strong nuclear force and weak nuclear forces. Now this gravitational force, same as the electromagnetic force, does not require any medium, okay, and it is always an attractive force. So electromagnetic force may be attractive or repulsive, but this gravitational force is always attractive. Now between any two bodies 1 and 2, the gravitational force acting between them is minus of capital G into m1 into m2 by r square, where capital G is the gravitational constant, m1 and m2 is the product of their masses, and r square is the square of the distances between the two bodies. Now this can be seen in this graph, this rectangular coordinate system. Means this mass m1 is located here, the mass m2 is located here. Now center of gravity of mass m1 is this and center of gravity of mass 2 is this. This is the center of this sphere. Okay. Now r1 represents the position vector of mass m1 and r2 represents the position vector of mass m2. Now this r12 is the relative position vector, means the relative position of 2 with respect to 1, okay, and which is also represented by r, which is the radial vector, which starts from the center of m1 and ends at the center of m2. Okay. Now this force F12 is minus of G m1 m2 by r square, and the direction is minus of r12. Okay, so r12 is from m1 to m2 and F12 is acting where? From m2 to m1. Okay, because it is an attractive force, so m1 is attracting m2. Okay, so F12 means m1 is attracting m2 with a force G m1 into m2 by r square. Okay, so gravitational force is directly proportional to the product of their masses of the two bodies and inversely proportional to the square of the distances between them, and always act along the opposite direction of the radius vector. Okay, now from the gravitational Newton's third law, F12 is minus of F21, means the gravitational force given by the body 1 on body 2 is minus of the gravitational force given by the body 2 on body 1. Both will have the same magnitude, capital G into m1 into m2 by r square, but the direction will be opposite. Now on any planet, the gravitational force will be mass of the body into the gravitational acceleration on that planet. Okay, so gravitational acceleration for the planet Earth is 9.81 meter per second square. So anything on the planet Earth will feel the gravitational force of m into g, where m is the mass of the body in kilograms and g is the gravitational acceleration having value 9.81 meter per second square. Now one case that we are studying in gravitation is the free fall. Okay, so free fall is the falling of a body under the action of gravitation. Means the air resistance is neglected, all other factors are neglected, only we are considering gravitation. So under free fall, if you fall a body, if you draw a body upon earth with initial velocity of 0, it will reach the ground with a velocity of root 2 gh. And similarly, if you throw a ball upwards with a velocity of root 2 gh, it will attain a height of h. Okay, and the final velocity will be 0 because it will deaccelerate. The deacceleration will be due to the gravity. So this is the formula for the highest velocity, means the maximum velocity attained by your object when fall from a height of h is v is equal to root 2 gh, and or h is equal to v square by 2g, means the height attained by a body if thrown with a velocity of root 2 gh. Okay, so this is the gravitation chapter. So thank you.